Math 3, practice 3.2.2, proving the law of cosine. So we have a law of sines, but that one doesn't always work because the law of sines, remember, when you had a triangle that wasn't right, you needed one side with one angle, okay, and then at least one other piece of information, and then you could figure things out, okay. Now, sometimes you may not have that. Sometimes you may have something like this, where you know this angle A, but you know side B and C. Okay? So in that situation, we have what we call the law of cosines. And the law of cosines is basically written like this, that C squared equals A squared plus B squared minus 2AB cosine of C. Okay? But there's another way to think about it. So if we look at this, it's the same formula, just written different ways, depending on what you have. Okay? So it's basically that the cosine of the angle and the other two sides can combine to get to the side opposite that angle. Okay? But that's a good one to have, to write it down in all forms if you're a little confused as to what they're doing. Okay? So let's get to using it. Alright, so it says number 1. Let's keep this triangle here. It says VWX, so VWX. Find the measure of angle V in degrees, so we want that angle. If VW is 15, WX is 10, and VX is 9. Okay, so you can use this different ways. You could use it to have 3 sides because you've got 1, 2, 3 sides. Okay, and then you can solve it for the angle. So in this case, C would be like this 10. So I'd go 10 squared equals, and then this is A and B, doesn't matter, 9 squared plus 15 squared minus 2 times 9 times 15 times the cosine of angle V, which is what we're looking for. Okay, so I cleared that out of the way. Now let's just solve. So this is 100. Okay, it says 81. 15 squared, I believe, is 255. Oh, plus 255. Minus, now this whole piece is together. So 2 times 9 times 15 is 270 cosine of V. So basically, we need to get this all by itself, and then we can solve for it. So 81 plus 255 gives us 336 minus 270 cosine of V equals 100. Subtract 336. We get negative 236 equals negative 270 cosine of V. Divide by negative 270. And anytime you're finding an angle, it's basically the same process. Okay, it's kind of lengthy. Cosine of V equals, so we get negative 236 divided by negative 270, and that's going to give me either simplified fraction or a decimal. Okay, I would take the simplified fraction and use that, because now we need to do the inverse of cosine of this fraction to get our angle V. And if you start rounding because you're doing a decimal, okay, you can run into some problems of being slightly off. So that's why I would do it that way and let the calculator do that stuff. So we end up with, let's see, it wants all in degrees, okay? So I've got to make sure my calculator, which I didn't, is in degrees. So I changed my calculator to be in degrees. And then I do this again, and we get 29.06, so just 29 because it wanted us to round to the nearest degree. 29 degrees equals V. And there's my answer. So yeah, quite a lengthy process, but hopefully not too complex once you get the formula. It's all about just getting that formula down and using that to find your answers, okay? So number 2, same idea. Okay, find the measure of angle O if NM equals 4, NO equals 5, and MO equals 8. The only thing you need to make sure you understand, and this is why I say draw the picture, is understand which pieces belong where. Okay, so NM is 4, NO is 5, MO is 8, and we want O. Okay, so we know that that's going to be 4 squared equals 5 squared plus 8 squared minus 5 times 8 times 2, right? Yeah, 2 in front. Almost forgot that. So let's go like this. Minus 2 times 5 times 8 times the cosine of angle O. Okay, then clear my space. We're doing the same exact stuff. So we get 16 equals 25 plus 64 minus 80 cosine of O. 25 and 64 give us 89. Remember, you can't go 80 minus 89. We have to subtract the 89. So we get negative 73 equals negative 80, because that minus always sticks with the 80. Cosine of O, divide by negative 80. Okay, now what you can do is just leave it 73 over 80. You don't have to reduce the fraction if you don't want to. And then we just find the inverse cosine of 73 over 80, and that's going to give us angle O. Okay, so if you're pretty familiar with it, it doesn't take too long to do that. But we get 24.14, so 24 degrees for our angle O. And that was number 2. Okay, let's just keep on trucking now. This one's just kind of got to get through it. Okay, find the measure of angle I in radians. So, once again, we know all the sides, so it'd be 16 squared equals 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of I. Okay, so 16 squared is 256, just double checking myself. Then 169 plus 121 minus 2 times 13 times 11. So 286 cosine of I. So 169 plus 121 is 290 minus 286 cosine of I equals 256. Subtract 290. We get negative 34 equals negative 286 cosine of I. Divide by negative 286. So 34 over 286 equals cosine of I. Take the inverse cosine of 34 over 286. That's going to give us I, so that's going to give us our angle. So I type that in, the inverse cosine of 34 over 286, and I get 83.17, so 83 degrees. That's my answer right there. Alright, number 4. Same process. It's making us do all of these ones. Hopefully we'll get some where we actually have to find the side, because that's a lot easier. That you can honestly just type into the calculator and it spits it out for you. So I guess it's good we're getting a lot of practice on these ones. So angle B, so 3 is my one all by itself. Cosine of B. So there's my formula. So we get 9 equals, sorry about that, caught me unawares, 49 plus 36 minus 84 cosine of B. Okay, I combine those and I'm going to subtract them from that. So 49 plus 36 equals 85. Okay. So negative 84 cosine of B is all by itself, trying to shortchange a few things here. So 9 divided by 85. Okay. Actually, 9 minus 85. What am I doing? That's why we don't shortchange things. So that's 85. Subtract 85 from both sides. There we go. Get negative 76. Now we divide by negative 84. So 76 over 84 equals cosine of B. So I take the inverse cosine of that, and that's going to give me my angle B. Okay? And we go 76 divided by 84. You get 25.2, so 25 degrees. All right. Okay, now let's take a look. 5, 6, and 7 want us to find all the measures of the unknown angles and sides. Okay, let's take a look at 7 first because it has a diagram. So, actually, let's not. Let's do 5 first. So 5, and I'm going to probably do it over here where I've got more space. And I'm going to use that triangle. So we've got RST. So let's call this RST. Okay, RS is 8, RT is 5. And angle R is 86. Nice. Now we get to do one where we actually already have the angle. So we're looking for that right there. We'll call it little r. So we go little r squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 86 degrees. Now, I can take the calculator, type it in just like that, and that'll give me my answer. Okay? I can do that. But I'm going to show you step by step just because I can. But personally, I would put this whole thing in, and then take the square root and call it good. So 25 plus 64 minus 5 times 8 is 40, times 2 is 80, cosine of 86. Okay, so I get 89 minus 80 cosine of 86. Now, I'm going to have to use the calculator at that part. So I go 89 minus 80 times the cosine of 86 degrees, making sure my calculator's in degrees, and I get about 83.4195. Now I take the square root of that, and that gives me side R. Okay, which is about 9.133. But I believe it told me to round all answers to the nearest whole, so that would be 9. Okay, so this side now we know equals 9. Okay, but it wants us to find the last two angles. Now we could try to use the law of cosines to find these angles, but once we've got an angle side connection, use the law of sine, so much easier. Okay, so I'd go sine of 86 over 9 equals, let's find t, sine of angle t over 8. So I times both sides by 8. So you often can use the law of cosines in conjunction with the law of sines. And we would get the sine of angle t equals this, 8 times the sine of 86 degrees over 9, which gives us about 0.886724. Then to find t, we take the inverse sine of that, to get 62.46, 62.5, so 62.46, so 62 degrees. So that's 62 degrees. Okay. Then to find the last angle, we just go 62 degrees plus 86 degrees, right, to get 148. Subtract that from 180, and we get 32 degrees. And there's our whole triangle, all the sides, all the angles. Okay. So number 6, we're going to do it the same way. And then number 7, notice how we already have an angle side connection. I'm not even going to bother with the law of cosines. I'm going to use the law of sines to figure these things out because it's so much easier to do it that way. Okay, so let's look at number 6. So once again, I'm going to draw on this page, give myself some room. So I've got ABC. AB is 9, BC is 4. AB is 9, BC is 4, and AC is 6. So once again, we're going to have to find an angle. Now, does it matter which angle we do? No, it's just that whatever angle you choose to do, that side opposite the angle is the one that is opposite. So then I'd write it like this. Those are multiplying. And then cosine of c. So then we solve. So 16, 36 minus 48 cosine of c equals 81. So 36 minus 16 gives us 20. 81 minus 20. So we've got 61 equals negative 48 cosine of c. Divide by negative 48. So I get negative 61 over 48 equals cosine of c. And then we go the inverse cosine of that fraction. Now, hopefully you spotted my mistake. I was getting way too ahead of myself, and I don't know where that 20 came from. 36 plus 16 is actually 52. So we subtract by 52. Okay. So we get 29 here, which then we divide by a negative 48. So we do the inverse cosine of 29 over negative 48, and we get 127.169. So 127 degrees for C. Okay, now we still need angle B and A. So now I'm going to use the law of sines to figure this out. So I'll go the sine of 127 over 9 equals, let's do B, sine of B over 6. So times both sides by 6. So I go 6 times the sine of 127 degrees. Take that and divide it by 9, and we get 0.5324 equals sine of B. So take the inverse sine of that number, 0.5324, and we end up with B equals about 32.169, so 32 degrees. Then I go 127 plus 32 to get 159, subtract it from 180, and we get 21. Yep. So 21 degrees for A. Okay, now if we look at number 7, notice we already have a connection, so don't use the law of cosines, use the law of sines. So I can find angle H by using the law of sines. So sine of angle H over 7 equals sine of 123 degrees over 10. Times both sides by 7. So sine of H is equal to this. Okay, so I go 7 times the sine of 123 degrees. Let's make sure that was degrees. Okay, divide that by 10, and I get 0.58769. Okay, so take the inverse sine of that number, and that's going to give me H. So the inverse sine of that answer gives me 35.9, so round up to 36, so 36 degrees. So then if I go 123 plus 36 degrees, subtract 180 from it, I get 21 again, 21 degrees. Now that I have J, I can use the law of sines again and go to get this little j, we'll call it, side over sine 21 degrees equals the sine of 123 degrees over 10 times by the sine of 21 degrees. Because I'm looking for the side, not the angle, I just type that in. So the sine of 21 degrees, oops, made a mistake, didn't I? I needed to rewrite that. See how I mix it up? That's a mistake you can make. This should have been 10 over the sine of 123. So I go the sine of 21 times 10 and then that's divided by the sine of 123 degrees, giving me about 4.27, or if I'm rounding to the nearest number, 4. And there's 7. Okay, now 8, 9, and 10. It wants us to determine the amount of fencing that would be needed to completely enclose each triangular plot of land, basically the perimeter. So all we're looking for are these extra sides. So law of cosines here. So we've got the angle, so we're looking for the side. So x squared equals my other two sides, 4.5 squared plus 2.8 squared minus 2 times 4.5 times 2.8 times the cosine of 34 degrees. So once again, I could, in my calculator, just write this. So I would just take the square root of the whole thing times the cosine of 34 degrees. Okay? That's honestly the easiest way to do this. So if you're using one of the Inspire calculators, you can definitely just type it in like this, and it'll do all that extra work for you, which makes life a lot easier, and you end up with an answer of 2.682. These are all rounded to the 10th, so I'd round it to the 10th, so 2.7. So then 4.5 plus 2.7 plus 2.8 gives us 10. So we'd need 10 miles of fencing for number 8. Now, if you don't have a calculator that you can type that all in, let me again show you how to do it by hand. So we've got x squared equals 4.8 squared plus 5.6 squared minus 2 times 4.8 times 5.6 times the cosine of 133. So I'd simplify those. So 4.8 squared is 23.04. 5.6 squared is 31.36. 2 times 4.8 times 5.6 is 53.76 times the cosine of 133. That all equals x squared. Then 23.04 plus 31.36 is 54.4 minus 53.76 times the cosine of 133 equals x squared. So then x squared would equal that 54.4 minus 53.76 times the cosine of 133 degrees. So that's like 91.0642. Take the square root of it, and we get x equals about 9.54, so 9.5. So the perimeter, 4.8 plus 9.5 plus 5.6 gives me 19.9 kilometers. Would be how much fencing we need. Okay, so either way you do it, it's that same process. So this last one, we set it up the same exact way that we've been doing, except this time we're doing radians, so it's just slightly different. So if I need to, I can go and change back to radians on my calculator. Okay, that's pretty important that you do that. So then we set it up. X squared equals 66 squared plus 49 squared minus 2 times 66 times 49 times the cosine of 3 pi fifths. Then we take the square root of that whole thing and we type it into a calculator, because that is the easiest way to do all of this. That way you're less likely to make mistakes as long as you type it in correctly. I mean, there's always a chance to make a stupid mistake. I do it all the time, where I type something in incorrectly. Okay, so we go 3 pi over 5, type it all in, hit enter, and we get 93.57. so 94. Then we add it all up, 66 plus 49 plus 94 gives me 209 meters. And there we go.